Hi, welcome to Calculus Stewart 6C, single variable, section 9, which is called related rates. I'm going to do two examples. This is called the ladder question, and this is called the inverted conical tank question. Example 3 on page 243 and 242, respectively. So on page 242, let's take a look at the question. A ladder is 10 feet long, rest along a vertical wall. So it's a 10-foot ladder right there. It doesn't move at all. Here's the wall, and here's your ground. If the bottom of the ladder is sliding away from the wall at a rate of 1 feet per second, so this is moving away at a wall 1 feet per second, how fast is the top of the ladder sliding down the wall? The bottom of the ladder is 6 feet away from the wall. So I'm looking for how fast this is sliding down when this is sliding 1 feet per second. Yes, and it's 6 at x equals 6. So what we're going to do is this is your x-axis and this is your y-axis. If you don't get your axis down, it's going to be pretty hard to actually solve this problem. And we know that xy direction is perpendicular. So here's your x direction, that's your y direction. And what is this length of the ladder? That's always going to be 10. So using the Pythagorean theorem, you have one equation, x squared plus y squared is equal to 10 squared. That's the Pythagorean theorem. And there you have it. Now it says it's going this way at 1 feet per second, right? So you have to, how to write this in mathematical notation? Well, if it's going in the x direction, it's dx over dt. That's going to be 1, positive. This going down, it's going to be dy over dt, right? It's going to be going in the y direction at the edge right there. And that's what we're looking for. Let's look at our gut. What does your gut say regarding dy dt? Well, dy dt has to be less than 0. Has to be smaller than 0. Why is it negative? Because if this is going positive, then this must be going negative. And so at x equals 6, we don't actually plug in 6 at this state right here. We actually plug it in after we take the derivative. So what do? We take the derivative with respect to time. Always. The previous section was with respect to x. Now it's going to be with respect to time. When we take the derivative with respect to x squared, of x squared to time, you get 2x times dx dt. So using the power rule, we bring it on down, subtract 1 on the exponent, and the derivative of the inside right here, that's going to be dx dt, plus 2y times dy dt is equal to the derivative of 100 of a constant is 0. And now we also know that at x value is 6. Now, after we take the derivative, we can plug in 6. We know what dx dt is. That's also equal to 1. What's my y value? So when this is 6 right here, it's going to be 8 because it's a 3, 4, 5 triangle. Or we could then a squared plus b squared equals c squared. 6 squared plus b squared is equal to 100. 36 subtract from 100 would be b squared is equal to 64. So b is equal to 8. So you end up with 2 times 6, which is 12, times 1, plus 2 times 8 times dy dt. That's what we're looking for, right? It's equal to 0. 12, 12 plus 16 times dy dt is equal to 0. Solving for dy dt, we're going to move the 12 to the left side, divided by 16. That gets rid of that. Oh, our gut said that it should have been negative, which it is, and it's going to be negative 12 over 16. Just reduce it by 4, you get negative 3 over 4. Does it give you units at all? Yes, it does. It's going to be feet per second. Negative 3, 4 feet per second. So as it goes, so let's look at it right here like this. Let's say this is the end of the wall right there with a wall in the ground. As the ladder, this is 10-foot length. As the ladder is going down, down, down. This is going 1 feet per second. At the top, it's going negative 3, 4 feet per second. Okay, that's it. Let's go over the next question. It's a little bit more difficult, the next problem. So this is going to be example number 3 on page 242. So, this is going to be a little bit more difficult, like I said, because you do have to do a little bit more work on this. Let's look at, read the example first. You have a water, has a shape of an inverted cone with base radius of 2. So that length is 2. It doesn't move. Height is 4. That doesn't move either. And if the water is being pulled at, pumped into the water, so water is being pumped right here at 2 cubic meters per minute. Find the rate at which the water level is rising. So as the water gets pumped in, that's your height, right? The height is going to go up. So when it says the water is rising, you're looking for dH dt, the height at which the change in height with respect to time. That's what you're looking for. When the water is 3 meters deep. So where's my meters? At h equals 3. Okay. And this is my radius right here as well. So what I want to do is I want to create a triangle with another triangle. I'm taking a cross section of this picture. Oh, they do also give you some other information, which is 2 meters per second. Water is being pumped in, right? So when the water is being pumped in at 2 cubic meters per second, that's the volume that's being pumped in. That's equal to 2 cubic meters per second. So you have all the information. Well, when we take a cross section of this, it looks something like this. That's 2. That's going to be 4. That's my radius. That's my height. What is the volume of a conic? Well, we're looking at the volume, right? The volume of a conic is 1/3 pi r squared times h. The volume of a pi r squared times h is the volume of a cylinder times 1/3 will give it the volume of a cone, right? So what we're going to do, before we do this, there's 2 variables. The radius is changing and the height is changing as well. So you want to try to get in terms of one variable if you can. And to do that, this is where the little trick comes in. See this right here? That's a key. This is a key. The key, I'm going to put keys in pretty soon. Keys what opens the door to knowledge. If you don't have these keys, you're going to have a little bit of difficult time solving this problem out. So let's draw the picture out again, nice and neat. That's 2, that's 4, that's my height, and that's what I'm looking for, by the way, right? And that's my radius. So these 2 triangles are similar. That means they are in proportion. 2 over 4 is equal to r over h. Cancel those out. 1 and 2 cross multiply. 2r is equal to h. And you want to solve for r, so r is equal to h over 2. And that's what we're going to plug r in here. So it's going to be 1/3 times pi times r, which is h over 2 squared times h. I'm going to write this as pi over 3. 1/3 times pi, same as pi over 3, times h squared over 4. If you distribute this out, make sure you get h over 4 times h is h cubed over 4. Simplify that. Volume as a function of h this time. Only variable h is going to be involved. It's pi over 12 times h cubed. Okay, because you have h cubed right there. 4 times 3 is 12. So what are we going to do at this stage? Now we got your function of the volume as a function of h only. At this stage, we're going to take the derivative with respect to time. The easy part on the left side is going to be dvdh, dvdt. On the right side, the pi over 12 will cancel out. Come out to the front. The derivative of h cubed is 3h squared times dh dt. This is the portion that's a chained. dv dt, they give it to you, which is going to be 2. So we're going to erase this picture a little bit and do it right over here. dv dt is going to be 2. It's equal to pi over 12 times 3 times what's the height? To give the height, it's going to be 3. So 3 squared times dh dt. That's going to be 1 of the 3 is going to cancel with the 12. It's going to be 4. It's going to be 9 over 4. So it's going to be 2 equals 9 pi over 4 times dh dt. Solving for dh dt, we're going to multiply it by 4 and then divide it by 9 pi. So dh over dt is going to be 8 over 9 pi. And the unit is going to be meters per minute. That's it. Let's see if we got that right. 8 over 9 pi meters per minute. Okay. You can plug in into your calculator to see what the actual number is, but in the AP exam, you don't have to approximate it. You always put the exact value. Good luck on your related rates questions, and I'll probably do about maybe 2 or 3 more later on. Take care. Good luck.